Solve the equation, check your solution. So here, I don't have anything on the left side to simplify or on the right side to simplify. They're each just one expression. I can either solve by proportions by cross multiplying, or I can multiply everything by my common denominator. My least common multiple here of each factor is just of each expression is just the denominators, which makes this my least common denominator. So I'm going to go ahead and multiply both sides by my least common denominator. And I don't have to do top and bottom here. The same way if we're solving 2x equals 4, we can divide each side by 2 just once. The same thing happens here. As long as we do it to both sides of the equal sign, we're still keeping it equivalent. So I take x plus 1 divided by x plus 1, and I take x plus 5 divided by x plus 5. Again, I keep whatever's on each side of the equal sign separate. So on the left side, I'm left with x plus 5 times negative 4 equals negative 1 times x plus 1. I don't have any denominators left. If we look, they simplified out. Negative 4x minus 20 when I distribute there. Negative x minus 1 here. Now we're just going to solve for x, and in order to do that, I just have a linear equation here, so I have to get all of my variables on one side, number parts on the other. I'm going to add 4x, and that moves all my variables to one side. So I'm going to add 1 and move all my number parts to the other. I'm left with negative 19 equals 3x. Go ahead and divide by 3. And x equals negative 19 over 3. Check our answers. We can either plug them back into our expression, which will give you the same on both sides, but and that'll tell you if your answer is for sure correct. The other thing we need to do is we need to check our denominators to check for any restrictions. X cannot equal negative 1 or negative 5, and I got that from my least common denominator here. That accounts for all of my denominators. My x value is not either one of those, which means it's not extraneous, but we could plug it back in our solutions and check. I'm not going to for time, but if you did, you would get the right answer. Some of you had negative 6.3 repeating. When we start with fractions, end with fractions. I didn't count them wrong, but we want to stay with fractions when we start with fractions. Number 18 here is the same idea. C minus 8 and C plus 5 is going to be our least common denominator. I'm going to go ahead and multiply both sides by my least common denominator. C plus 5, C minus 8 times C plus 5, C minus 8. And again, it works the same way as it does when we divide both sides. As long as we do the same to both sides, we keep them equivalent. So here, C minus 8 and C minus 8 cancel. C plus 5 and C plus 5 cancel. What I'm left with is C plus 5 times C plus 3 equals C minus 4 times C minus 8. Okay, we had fractions, we didn't want them, and because we have an equal sign, we can clear our fractions. On all the problems before this back page, we had to keep a denominator because we can't do things like that without an equal sign. It only works if we go across to the other side, if we change both sides. But if we don't have an equal something else, we have to keep everything accounted for. So some of you got the right numerators, didn't have the denominators, and we need them because we are not solving there. We have to keep everything accounted for unless there's an equal sign. And when there's an equal sign, we can simplify by doing the exact same thing to both sides. So here I'm going to go ahead and simplify by FOILing. C squared plus 3 plus 5 is plus 8c plus 15. C squared Minus 8c minus 4c is minus 12c plus 32. It looks quadratic here, so I'm going to go ahead and put my c's squareds together, and when I do that, I see that they cancel out. So it's not really quadratic. You can set it equal to 0 if you want to, and then you'll recognize you need to solve for c again. That would have been fine. But what I'm going to do is I'm going to go ahead and add 12c. Get all my c's on one side, and subtract 15 to get all my number parts on the other. So right now, what I have is 20c equals 17 divided by 20, and I get c equals positive 17 over 20. My restrictions are c cannot be 8 or negative 5, which isn't a problem here. We could plug 17 over 20 into our original equation. Check the left side and the right side, and what you get should be equal to each other. Here it would work, but that's how we check these when it says to check. Mostly I'm concerned about checking for extraneous solutions because I know that these will work. Okay, 19. This one's a little bit different. We have to simplify the left side, or we can still keep multiplying everything by the common denominator. If we wanted to, we could put everything on the left side together and then solve like proportions. Difference of squares here, so a plus 6, a minus 6. Common denominator. First expression, second expression, third expression. So when I put all those together, the most my denominators ever occur is a single a plus 6 and a single a minus 6. So I'm going to go ahead and clear my fractions. Again, you could have combined your left side into one and then use proportions. But I'm going to go ahead and clear my fractions. So I'm going to multiply the top, every fraction by a minus 6, a plus 6. That's my common denominator. And we only need to do it once to each fraction because we did it to both sides. I can simplify here, a minus 6, a plus 6. All I'm left with is a. A minus 6's cancel, so I'm left with 2 times a plus 6. And here the a plus 6 cancel, that should have been a plus 6, sorry. One of them should have. And I'm left with 1 times a minus 6. I'm going to go ahead and simplify here. If you notice, all the denominators canceled out, and that means I have the right common denominator, and I simplified right. Don't just cross them out and be like, oh, this is probably going to work. Double check and make sure it works as you work through the problem. Here I'm going to distribute. Okay, combine like terms. Get all your variables together on one side, and all of your number parts on the other. It's going to give me 2a equals negative 18, divided by 2, and a equals negative 9. If I plug negative 9 back in, it should work. My restrictions here are a cannot be negative 6 or 6. It's not an extraneous solution. And again, if I plug it back into all of my a's, it will simplify and both sides will be the same. 20. This one I'm going to do by combining the left side just to show another way of doing them. Common denominator, because some of you might do it this way and that's totally okay. 1 is just 1 over 1. So right now I have an x minus 3 times x plus 3. I have an x minus 3, and I just have a 1. So my common denominator is going to be x minus 3, x plus 3. On my left side, that's all I'm worrying about right now. I already have the x minus 3, x plus 3 in my first, but in my second, I just have the x minus 3. I'm missing the x plus 3. So I have to go ahead and multiply top and bottom by x plus 3. Here I'm combining the left side first. So what I have right now is 6 over x plus 3, x minus 3, minus x plus 3 over x plus 3, x minus 3, which I can combine. Again, remember this negative goes to both pieces. So I have 6 minus x minus 3 over x plus 3, x minus 3, which gives me 6 minus 3 is 3, minus x over x plus 3, x minus 3, equals 1 over 1. I can cross multiply here. Gives me x squared minus 9. I just FOILed that back to where we started. Times 1. And I have 3 minus x times 1. I crisscrossed, multiplied. That's how we solve proportions. Multiply by the, we cross multiply. And it's just clearing our fraction. LCD, LCD. To get rid of the 1, we multiply by 1 times 1. And it ends up working out just fine. Okay, here, since it's quadratic, I need to move everything to one side. So I'm going to add an x, subtract a 3. X squared plus x minus 12 equals 0. Factors to plus 4 minus 3 equals 0, which means x equals negative 4 or positive 3. Let's check our restrictions. X cannot equal 3 or negative 3. So 3 doesn't work, but the negative 4 should. And again, when you plug that back into the original equation, you'll get the same solution on each side. 21, I have an a and a 3a. So my common denominator is a times 3 or 3a. My restriction a cannot be 0. So here, again, I'm going to simplify the same way I did on the last one. You can either do it like problem number 20 or like 19. I'm going to do it like 20 just to get another example of that way for those of you that prefer to do it this way by combining your terms. I have the a. I am missing the 3. So I multiply top and bottom by 3, which gives me 12 over 3a plus 5 over 3a. Common denominator, 3a, combine my numerators, 12, equals 3. And we write whole numbers as over 1. I can clear my fraction here, multiply by 1 as well, to cross multiply. I get 12 equals 9a. Go ahead and divide by 9. And a is going to be 17 over 9. My restriction is a can't be 0. This looks like it works. If you plug it back in, it will as well. And again, once I had the 17 over 3a equals 3, you can either write it over 1 and cross multiply, which is what I did over there, or we can clear our fraction by multiplying by it. When we have a fraction and we don't want it, we just multiply by the denominator to get rid of it. 3 cancels, a cancels, I'm left with 17 equals 9a. Divide, and we get to here. So we could have started from the beginning by multiplying by 3a as well, and I would have had 17 equals the 9a there. So again, does not matter which way you do those, as long as you get where you're going. Lots of different ways we can solve these depending on what makes you most comfortable. If you have questions on these or which way is the best, or you like to do them a different way and aren't sure because I didn't show you that way, aren't sure where you messed up, then stop in and we can figure it out. Thanks.